Great, great. So we are ready to go. So hello everyone, and welcome to today's ACM Tech Talk. So this webcast is part of ACM's lifelong commitment for learning and professional development, serving this global membership for computing professionals and students. I will be today your moderator. My name is Alejandro Saucedo. I am currently member at large for ACM's governing board, as well as Director of Engineering, Science and Product at Zalando. I am also a scientific advisor at the Institute for Ethical AI, where I've led contributions to EU policy, including things like AI Act, Data Act, etc., etc. So for those of you who may be a little bit unfamiliar with the ACM or what it has to offer, here is some information. So ACM offers educational and professional development resources that bolster skills and enhance career opportunities. You can see some of the highlights on your screen. So these are basically some of the key areas that ACM is known for. Some of the things to highlight that are worth noting is that ACM provides access to what is referred to as the ACM Digital Library. This is the world's most comprehensive database for computing literature. ACM also provides leading publications and global conferences that draw top experts from a broad spectrum of computing topics. They also provide support for education and research, including curriculum development, teacher training, and perhaps also you may have heard about the ACM Turing and ACM Pricing Computing Awards. As well as the ACM Code of Ethics, which is a collection of principles and guidelines designed to help computing professionals make ethically responsible decisions. So we have also published just recently things like the generative AI principles, which are of course using this as the backbone, as well as the principles for algorithmic responsibility, which also served as the backbone for several of other of the ACM policy products. Before we get started, let's mention a couple of housekeeping rules. If you have any questions at any time, please type them in the Zoom's Q&A button. I know that you can also use the chat, but the Q&A button will allow us to collect it more systematically. We will then be able to raise them as the talk finishes. This session is being broadcasted and recorded. And it will be archived. So you'll receive an email notification when it's made available, and check learning.acm.org for updates on upcoming webcasts. So today we actually have a very, very exciting topic with also a very exciting presenter. The presentation is titled From ML Engineering to AI Engineering, and we will be having Chip, who works to accelerate data analytics on GPUs at Voltron Data as their VP of Open Source and AI. Previously, she was at Snorkel AI and NVIDIA and founded an AI infrastructure startup that was acquired. She has also taught machine learning systems design at Stanford, and she's the author of the book Designing Machine Learning Systems, which is an Amazon bestseller in AI. A lot of the insights today are going to be providing a lot of depth on this. So with that, and without further ado, Chip, please take it away.
Thank you so much, Alejandro, for the very kind intro. And hi, everyone. I'm just looking at the chat right now, and it's incredible diversity in the audience. So feel free to ask questions when I'm speaking. And I know that sometimes when I get excited, I speak pretty fast. So feel free to tell me to slow down as well. So wait. Oh yeah, somehow my video was not on. I hope you can see me now. Hey, hi again. So today I'm talking about from machine engineer to AI engineering. As Alejandro mentioned, I'm the author of Designing Machine Learning Systems, and I'm working on a new book that is similar, like just built on top of Designing Machine Learning Systems, but focused more on foundation model. So it covers everything from engineering, evaluations, fine-tuning, context retrieval, actions, agents, and all the things that you might have questions about. So in the process of working on this book, I do a lot of research. So I try to look at every single AI tool out there, and it's a very time-consuming things because there are so many of them. So to make my life easier, I only focus on repos with at least 500 stars. So you can actually see them on my blog, on my website at huyenchip.com/llamapolice. So I think I find it pretty useful to so like if I'm wondering like who is doing inference optimization, so you can look at like I can filter them out by the category of like inference optimizations. I want to see like who is doing Asian, who is doing AI, who is doing coding, who is doing serving. So it's been very helpful. And you can see like the number of changes, like because I noticed a pattern, just like what I call is like the hype curve. So you will see a lot, like sometimes a repo come out and you see a lot of excitement and a lot of stars, but then nobody ever uses this again, and it was just like flatten out. So I think it's useful to track like not just the number of stars, but like how fast this is growing. Okay, so today we talk about AI engineering. So AI engineering is the process of building applications with foundation model. So I use the term foundation models because it's a superset of large language model. So I do think it's like we were seeing the convergence of a lot of different modalities. When I started out in AI in 2014, we saw that like NLP, natural language processing, was its own field. Computer vision was its own field. Like reinforcement learning was its own field. But I do see that like things are like coming together. So we see that's like a lot of models today, like GPT-4 or Gemini, their own incorporate not just text, but also images. And we see reinforcement learning being used to train models. So it's like reinforcement learning from like human preference. So it's been very interesting to see that. And foundations, I think the term was coined by Stanford because it also denote the ideas that the concepts that foundation model are just lays a foundation and there is a need to be adapted to specific needs. So there are a lot of changes in from like machine learning engineer to AI engineering. So one thing is that models are getting really big and very few people can afford to train them. So we see there are like model providers, model developers who develop models and make them available to use as a service. So this service you can access through API or you can download them like as an open weight model and you can host them yourself. So this means that like anyone, even those with no AI knowledge, can now leverage AI to build applications. So before, right, like only the company who could afford to build AI applications as a big company to have data who can train their own model, and then these companies and then these AI products are incorporated into their main product. But now, like you can just build it, but then you need to figure out a way how to serve those applications. So one thing is very exciting that we see a lot of interface to serve the AI applications, such as like plugins, so you can incorporate AI into the browsers, Google Docs, or like VS Code. You can also see, I'm very excited about like getting like embodiment of AI. So for example, we can have like audio or like 3D character. I think like the ultimate goal is that we have like AI embodied in like physical robots that can have us do things around the world. So yeah, so I think that AI has become a common component in software engineering, the same way that JavaScript and databases are. So I noticed it's like engineering is coming like closer to full stack than like traditional data scientists. So another change is that we are moving away from like we are moving from closed-ended evaluation to open-ended. It's not moving away. It's more like we need to combinations of a lot of ways to evaluate. So foundation models can generate open-ended responses, and this makes them really really powerful because now with open-ended responses, you can adapt them to like different use cases. Well, thank you. Yes, I'm gonna try to speak slower. Yeah, so yeah, open-ended responses make being open-ended makes foundation models useful for a lot of use cases because now you can ask, like, say, GPT-4 to do translations, to write essays, to write code, to do math. However, the open-ended nature of models also make it really, really hard to evaluate. So before, if you have, say, a classification task, right? So you have the model putting maybe like one of the three categories. And say if you expect category like positive and the response is not positive, then it knows that the response is incorrect. But now it's very hard because there are many different ways to express the same idea. And even if the model outputs something that's like not the same as the expected sentence, expected text, it's really hard to tell whether it's incorrect. And also, like as models get more intelligent, it also becomes harder to evaluate them. So imagine like anyone can tell if the solution to a first grade math problem is wrong, but it's very few people can tell whether the solution to like a PhD level math questions can is wrong. So now that like the less obvious mistake we can detect from AI, and so the incorrectness or like inaccuracy of AIs, now you have to like do fact check, involve critical thinking, and make it a lot harder to evaluate. So we are seeing a lot of new evaluation approaches for AI applications. So one approach is comparative evaluations. So basically, you see with this approach, you see two different responses side by side, and users pick which one is better. So this is different from A/B testing because in A/B testing, you only see one response at a time. Another approach that usually cause a lot of controversies, but I do see that it's getting more adoptions, which is like using AI models as a judge. So you can ask, sometimes I think of it's like using, evaluating whether an AI model is good by like asking his friend. So you have a model to generate responses, and another model or is the same model to evaluate whether that response is good or not. So there are many different ways AI judges can be formulated. So one way is just like a scoring, like a reward model. So a scoring is you ask a model to output like maybe a score from 1 to 5 on the response whether it's good. A reward model or like some other models can also do comparative evaluation for you. So you can ask a model to like pick which of the two responses that humans would prefer. So I'm very excited about this category of AI judges, because if we could find a reliable way to like predict what humans prefer, that could be the goal, right? We wouldn't need a lot of like humans annotation to create data to train the model, because like human preference is what like a lot of people want for their models, because for this model to align with what humans want. Yeah, and so like other AI has judges, like you just ask the model like, hey, does this sounds correct given the answer, or like is this like relevant to the questions? But it's exciting, but it's like very hard to use because you need a lot of rigor in like making those metrics standardized. Seems that we are doing okay. I'm still speaking pretty fast, and I don't see the audience. It's by take a out approach evaluation. We will get back to this later, maybe in the Q&A. I love that. So I actually had a conversation yesterday with a few friends, and some of the smartest people I know. I was asking them like, how do you evaluate the model? And they were like, oh, we have about like 5 head respond, like 5 queries, 5 prompts that we use to test. And was like, wow. I think it's like vibe check is very important, but it's not sufficient. So you do need to like interact with the models every day, like to manually see that to like for because like, over time you might have better idea, like as you interact with the model, you have a better idea of like whether what is considered a good response. One of the hardest challenge of evaluations is like creating the guideline. So my friend, he used to like like create guideline for annotators, but then you need to like, it's really hard to define. Like sometimes you sometimes need like to train people to do so. So yeah, so like one thing is that you have to create very clear guidelines to like what is good and bad, and only by interacting with the models that you can have a better understanding of like, is response really good or not. Because sometimes a response can be good but not sympathetic. So LinkedIn has an interesting case study. So they found out that like for they call this like job assessment chatbot. So when a candidate see a job posting, it can ask AI like, hey, am I going to be a good candidate for the job posting? So the AI can respond like, no, you're not, right? So even though it's correct, it's not very sympathetic. So they need to change the response, the guidelines, and like what would be a good response. So the response was like maybe like more encouraging, like today you're not, but if you go to this skill ABC, then it would be a better fit. And here's the resources you can use to like go to make yourself suitable for this role. So I do think that evaluation is the biggest challenge for generative AI applications. So one corollary of evaluation is like, if we don't have a way to evaluate whether model responses are good or not, there's like too much, like it can make AI application too risky for a lot of applications. So today we see a lot of enterprises using deploy AI applications, not because these applications are potentially the most impactful, but they are the easiest one to evaluate. So for example, a lot of people want to do, say, recommended system, because for recommended systems, you can evaluate the impact very clearly because it will increase something like click-through rate or purchase through rate. Or a lot of people do coding, because with coding, you can evaluate model using a functional correctness. So it's a model generated piece of code. You can execute the code and see if it runs and whether it produces the expected result. So because of that, if we can find a way to reliably evaluate responses, it believes that we can unblock a lot of exciting applications. Okay, so another thing is like I also see more of the transitioning from like feature engineering to context constructions. So with classical machine learning, you need to like engineer features. Like what would be so that for each of the query, it would need to like create the features that's important to that's what you think would be useful for the model to make predictions. So with generative AI model, foundation models, they use prompt. So for queries, you need like you need to inject useful information to the prompt, to the context, so that the model can respond to the query. So hallucination is an interesting term, because hallucination make it sound like a bad thing, but it's not always necessarily a bad thing. Like you do want model to like sometimes like be creative, so it's actually very useful for creative applications. But sometimes like for a lot of use cases, when you demand a strict like so some use case when like accuracy is very, very important, like legal or medical, you don't want models to like make up things. So we do see that like many studies have shown that like models are more likely to hallucinate when they don't have the right information. So so models have this, I think it's like the bias toward actions. So even when they don't know something or they are unsure, they just somehow like have to respond, and it has to like make up something like if it don't know the answer. I'm not quite sure like how to correct that. So I think part of the training, because like in the training process, right? For all the training, usually have like prompt response. So every prompt isn't, so there had to be a response. So I do think this like to correct that bias is going to be quite challenging. But anyway, in the meantime, when you work with this model, we have seen that models can perform much better and hallucinate a lot less when they are provided with the necessary information to answer the question. So like, how do we enhance context? Like, how do we provide models with the correct, with the relevant information necessary for it to like respond? So we can do it two way. Like once it like with retrieval. So you provide access to your databases, which should be the documents, images, tabular data, so that the model can retrieve the relevant information from the databases. Or you can also give model access to tools so that it can gather information yourself. So some tools like web search is extremely useful. So when the pattern of giving model access to tools is also known as a agentic pattern. And we can go into more into this in the Q&A if you're interested. I think it's very exciting, but it can be a little bit overhyped, because you can think of like, yeah, we can go more into this later. So here's some like visualizations of what enhancements, context enhancement would retrieval look like. So you give the model access to external databases, so it should be like a collection of documents or images, and you have a retrieval system. So like given a query, it will retrieve the relevant information from the databases, and then the context is joined with the query so that the model can generate a response and send back to users. So retrieval is old science. So it's not new. I believe that's the first digital retriever systems was described back in the 1920s. So it's like a century ago. And retrieval has been a backbone of like search and recommender systems. So it's not new. So they have many technology algorithms developed for retrieval search. So in general, there are two main approaches to a retrieval. One is term-based. So first of all, like keyword search. Like if you have a query like about, say, transformer architecture, it can look into the database and search for all the documents that contain transformer architecture. So there are a lot of term-based solutions that are available, like BM25 and Elasticsearch. None of them is new, but they are very, very powerful, and like they're a lot easier to study than the other approach, which is embedding-based retrieval, or like some people call it, like a lot of people call it like vector search. So vector search is more complex. It's like take longer. Is more computationally expensive, but it can potentially provide like much stronger performance because you can have a lot of room for fine tuning. But at the same time, I do think it's like if you're just starting out, I do think that like I do think that a term-based solution like BM25 is a very robust approach, and it's a very, very strong baseline to beat. So when you retrieve data, right, you don't just retrieve unstructured data. You also want to retrieve like tabular data as well. So maybe you have like a SQL database with a lot of SQL tables, and I have an example here. So retrieving tabular data is very different from retrieving like unstructured data, because now to retrieve data from this a SQL table, you need to like write SQL query. So the first step would be like you have to convert from like sort of query in a natural language into the SQL query, the flavors that your database can understand, and then after that you execute the SQL query. So it's like a bit trickier, and it can be quite dangerous. So say like, what if like people want to like execute a dangerous SQL query, like let's drop the table or something like that. So you would need to like put in guardrail, like what kind of queries that you can the model can execute. So yeah, so in this case, also text to SQL is also pretty tricky because I to generate a SQL query, you need not just a query, but also need to understand the table schemas. So like say if you have a lot of tables and the table schemas is too long to fit into context length, it could be hard. And also like to be able to like pick like what tables are relevant. So some people are trying to build embeddings for tables based on the table descriptions and table schemas. So that for a given query, it can automatically retrieve only the relevant tables, and then based on the schemas of this relevant table, generate a SQL query for those. Yeah, so here's an example of like a text queries that can convert into SQL query, and it would need to know that you are using the table called cells. So yeah, you can also use retrieval tool. So here's what it looks like. So basically, you can need to give models. You need to define a set of actions that that the model can take. So action could be like using a search API, using a news API, using weather. And I think the most exciting tools that people wanted for AI, like especially on ChatGPT stuff, was like web browsing, because now with web browsings, you can allow model to stay up to date. So with our web browsing, right, like information can be like models can get outdated. So if you ask a model about something that happened today and the information is not in the database or it was not in the model training data, the model won't be able to respond. But with like web search, the model can stay a lot more relevant. I think like web search is like very exciting. Okay, so I grouped all of this retrieval from databases and actions into what I call like people call like context constructions. Yeah, so like the goal is to enhance context so that the models can answer questions better and also reduce hallucinations. Okay, so another change. I know that we have been going through like a lot of content. I hope that is fine. It's okay, but now feel free to ask questions. We don't have time to go over them. So the model is gonna get become bigger. So I remember in the early day, we thought it's like, oh my God, 1 billion parameters was like so much. That's crazy. Like I remember when the first GPT model came out, so it was like 117 million parameters, and it was like, oh my God, that is so big. And now we're like hundreds of billions, and I think people are aiming for like 1 trillion parameter models. So the number of parameters is not the only things that matter, right? It also depends on how sparse the model is, because like the more sparse model is, so the faster, so the less computational resources are required to run the model. But anyway, in general, bigger models require more computational resources to run, so they are more expensive to run. They also have higher latency, and also it's just like if you want to host those big models, it's require more expertise, because like you just don't simply put it on the machines. You need to work on like distributed system, how to load data, how to shard data. So it's a lot harder to operate larger model and then smaller model. So that also making that like a lot of technologies to make this model run faster and make them smaller very exciting. So one thing that I'm very excited about is like inference optimizations. So inference optimization is not new. So when I'm like just so actually I used to take a course at Stanford about 5 years ago, not 4 years ago. Wow, time flies. But I was like covering inference optimizations, and then I revisit the topic again. Oh, sorry, people still cannot hear me. Okay, I'm gonna try to speak slower. Yeah, so when I revisit the topic of inference optimizations recently, and I realized that a lot of the core techniques for inference optimizations still remain the same. So like the core thing, for example, like quantizations. Quantization is extremely exciting. It works pretty well, like for a wide range of models and applications. It's not new, right? It reduces the precisions from like float 32 to like float 16, and now 8-bit, and now people are even going for like 4-bit. So another technique is lowering factorizations, which is basically like the core of like on the LoRa fine-tuning technique, and also like they're like sparsity with pruning, and now there's a new thing, a mixture of experts, and also with distillations, where you trained a smaller model to imitate the behavior of the larger model. And of course, there are things like cache, parameter efficient fine tuning. So all of that space is very exciting. Okay, so that is pretty much for my presentations. Just for one last thing I want you to cover. So like there are like, I think of like there are so many adaptation techniques out there, like to adapt model, but I would generally put them into like 3 categories. Like one is like just prompt engineering. Like so you try to write clear instructions, decompose like a big task into like smaller subtasks, adding a lot of examples. And then the next one is like context optimization. So here I put RAG, but they can be also like action API as well. So there's the general retrieval plus actions. And the other category is like fine tuning. So fine tuning, I would say, is like, it's never the first answer. So I would say over time, as you progress through the applications, I think it's very important to like get the most mileage out of prompt engineering with like use good examples with very clear guideline for like the model, like good example of like how the model should act. For example, if you want model to say give a score from 1 to 5, define very clearly what does 1 mean, what is an example of an 1 look like, and why it get a score of 1, and the same thing for 2, 3, 4, 5. And after that, you can try with like simpler like retrieval, for example, like BM20, like keyword search or BM25. And after that, you can choose to whether go to more complex retrieval, like vector search, because it would require you to like use an embedding model and use a vector database, or like sorry, vector search, which can be used as part of a vector database. So yeah, so like because it's add more component to the system, it increases the complexity. Or you can also go the fine-tuning route. And then you can also like join them together, like using RAG with a fine-tune model, or using RAG to like create training examples, like to fine-tune the model. So yeah, so I think that it was what it looks like. So in general, I would categorize. So I would decide what techniques you use also depends on what kind of behavior you want the application to have, or like what kind of issues you want to correct for the applications. So I would in general think of them as like failure modes could either be information based, so like when the response are incorrect or just outdated, or another what I call is a behavior based failure modes. So when the responses are like factually correct, but it's like either irrelevant or it just doesn't follow the expected format. So for the information based errors, I find that RAG, like context optimizations, helps really well. But for behavior based, like getting the model to like follow the format, then you can try that with like prompting, adding more example, using validators, using some fancy technique like constraint samplings, or using like bigger models, because as models become more powerful, they're also getting better at like following instructions and generating the correct format. Or you can fine tune. So fine tuning was think of like as a last line of defense, because fine tuning is exciting, but it's also require both a higher upfront cost because you need to curate data for fine tuning, and it also require continual maintenance because you have a model and what, right? You have to update it regularly. And like what if the newer model, base model comes out? Do you want to leverage a new base model, which means you have to like maybe fine tune again? So it's a lot of like cost associated with fine tuning that you really should consider before committing to it. Okay, so this is like a little bit ready to talk. It's about like what our work is doing. So we build GPU native query engines. So the idea is that GPUs now are everywhere. So I think one consequence of AI is that like now a lot of companies have GPUs and a lot of people are using GPUs for inference and training. But I do think a big category is like data processing, or like ETL. that I do think this like can be very suitable for GPUs, because let's say if you want a model, if you want to process a billion rows of data, you can just farm them out to like thousands of cores of GPU. So you can speed things up, and we can also like just make things like a lot cheaper. We also contribute to open source project like IBIS and Apache Arrow. Yeah, and if you want to find me, you can find me on my blog, LinkedIn, Discord. So yeah, thank you so much, everyone.
Great, great. Let's please all get our virtual hands together to give applause to Chip. This was a fantastic talk. Also, big props, Chip, for also keeping an eye on the chat. Very, active reactions on some of the comments and even the questions. So we have a lot of really great discussion and much more to come. We have been able to group some of the questions into different topics. So we will dive into what seems to be areas of hallucinations, RAG, prompt engineering, AI judge, evaluation, Gen AI limitations, and a couple of others. But maybe why don't we start with a more general and overarching question? So, Chip, how do you, how do people know what to learn about Gen AI, given that the field is just changing so fast?
Ooh. So, generative AI, a lot of applications enabled by AI, generative AI are new, but a lot of technology surrounding it is not, right? So for example, like vector, like a retrieval is not new at all. Or like on a lot of inference optimization, like quantizations, distillations, also not new. The concept of language modeling is not new. Like it was introduced in like 1951. It's like a really, really good paper, like Carl Shannon's paper. So a lot of the concepts are not new. So I would say just like there are certain fundamentals that I could recommend people to get started to realize this learning approach of like going in depth. So like I know actually I try not to read news because I find news very distracting, and usually there's a companies with the biggest marketing budgets usually like dominate the narrative. So I try to like focus on like, okay, what problems I want to solve. And then I look into the solution to solve that problem. And I find out that like one skill that would never go away is problem solving. Like given a problem, like look possible solutions and don't just like pick the like fanciest or like most hype solution, right? Pick a solution that is like works best for you. So yeah, like pick a solution, pick a problem you want to solve and look at different solutions. And then in the process, I think like Drake particularly is like on-demand learning. It's like when you encounter a new sub-challenge on that, like you find out, like learn more into the concept, like why is it a problem? So another thing is like when reading or learning something, people tend to ask like what and who. So like, okay, what is this doing? Or like who's doing this, right? But I think an important question is like why. So for example, like if I read about like mixture of expert, I was like, why do they using 8 experts instead of not like if I read about quantizations, it was like, why are we doing 8-bit? Why can't we just use 1-bit? Like what's the limitation here? Like what makes this hard? So like we're trying to understand like what why are people doing this? Yeah, and why is this hard?
Great. Yeah, no, I really like that. So ultimately understanding that it's built on foundations, getting your hands dirty, and also some really good tips. There were quite a lot of questions, interesting questions on the topic of hallucinations. So maybe before we dive into some of the specific questions on this, maybe can you also explain a little bit more about like what are hallucinations in the context of Gen AI, and also what are your thoughts about hallucinations?
So it's pretty funny because like the term hallucinations in AI has changed over time. Like originally, right, everything that's created by AI is hallucinated because it's not real, right? It's how AI came about. AI created those. But I think it's like hallucination now usually means that when it's only really a problem when AI generates something that are factually incorrect. So the hallucination is not a bad thing. Like say if I want to use AI to generate artwork, the hallucination is actually good because it's like you want something like some creativity, something that hasn't existed before. So what I could focus on like factual inconsistency. So like factual inconsistency. So you want to measure. So I would divide them like 2 types of factual inconsistency. One I think of like as the local factual inconsistency. So it's just like when you have a fixed knowledge area and whether the response is like consistent with it or not. So let's say just like if you have an essay to say the sky is purple and the moral there is like, oh, the sky is purple, then even though like it's not correct, but it's consistent with the essay. So I would still say it's factually like consistent. But there's like global factual inconsistency, right? It's just like based on information out there. For example, like does vaccines cause autism, right? So you don't want to like so to me as a question, and AI has to leverage on the knowledge it knows it has access to answer those questions. And sometimes the hardest part of it is trying to determine not the verification, but to determine what the facts are. Because when you leave AI to itself, like going through the internet and with a lot of like misinformation and people just like voting for like likes, it's really hard to differentiate. Even like for humans, right? Like it's really hard. So usually to make the task easier for AI, we focus on a local factual inconsistency, which means that we provide AI with a ways or guidelines or access to like information that's relevant. So the job of AI now is like to focus on like extract information from that instead of trying to determine like what is the factual thing to do. Why is that why I think like context enhancement is like so useful for to deal with factual inconsistency.
Mm-hmm. Yeah, no, that's quite interesting. So I like that. Kind of direction of in factual contexts, we need to make AI boring, and in others, it has to be creative. So that's really interesting. And maybe also then diving into the topic of RAG. The interesting thing is, we have quite a large audience, and we're getting all the spectrum of questions, some very, very specialized and very advanced, also some more foundational. Before diving into questions related to RAG, I think it would be great if you can maybe paint a picture, set some intuition of, what RAG could look like in practice in regards to prompt engineering. Like, what would a prompt look like in order to suddenly make an LLM being able to talk to a database? Like, how can AI do that? If you can maybe just give us some of that intuition, less architecturally, and maybe just like, what does that look like in a prompt?
So things is, let's go through this, right? So let's say I have a query of like, tell me about the movie Inside Out. So the retriever, like first the query is sent to a retriever system. So like it could just be like an API keyword search, and it's like going to the documents. So and it's using an example keyword search. So it identifies the keyword here is inside out, and it was just search on the document to see which one contains inside out, and that is just like paste the document into like here are the documents for inside out, and here's a query. Tell me about the movie Inside Out, and the model takes that as the context to generate a response and say like Inside Out is a movie by Pixar, blah blah blah, and send it back to users. Yeah.
Yeah, and I think then the follow-up question to that, which it answered, it had asked basically, did RAG actually replace fine-tuning?
So they address different problems. So maybe let me see. I can actually have another slide. So I just gave a talk on Tuesday that actually covering this. Like, yeah, let me see. So I would see like so I do think of like there are two approach to picking the solutions. Like sometimes it can be solution focused, right? Oriented. It's like, well, here's a solution I want you to use this. How do I use this? Another approach is like problem oriented. It's like, okay, what problems do I have? And then I see like what solution is best suited for that problem. So I would categorize them as like, usually if you want to enhance, if you want to like, fix information-based failures, when the respondent usually like outdated. So first of all, here's an example of like an outdated response, right? Like if it's asked like how many studio albums has Taylor Swift released, and if it respond like 10 instead of 11, it's likely because the cutoff date was before the date the last album was released. Or you can also see that's like you can also check yourself. Like sometimes I find that like models are more likely to hallucinate when you ask them about a very, very niche information that's unlikely to appear in the training data, or just like very rare, like it doesn't appear a lot. So you can do that like by, so that's when Infinite Rack is very useful. But then if you see the problem with, so there are a lot of research showing that like Rack and retrieval can work quite well for like a lot of benchmark. So you can see like base model plus Rack on this paper, and it's a very interesting paper that base model plus Rack usually works pretty well. But sometimes using Rack on fine-tune model can also like give better performance. So I think about 40% of the time, Rack on fine-tune model also like does pretty well. In almost no cases where fine-tune is like perform better on ML on this benchmark. But it's not necessarily the case, right? Because there's some use cases where fine-tune can work better, and usually they are related to the use case of behavior-based failures. So you can notice them as like when the outputs are actually incorrect or irrelevant, or when the outputs don't follow the requested format. And there are a lot of ways to like enforce this behavior, like prompting validators, use a better model like we already talked about, and fine-tuning. So yeah, so I would say like, I think Rack replace fine-tuning is just more of like what problems do you have, and there are different solutions, and whether Rack or fine-tuning works better for the problems is like really depends.
That's great. Yeah, and I think it was also fantastic that you were able to pull a new set of slides to do a deep dive. I think the content you will always have yeah, a reference for the audience. We also shared the link to your website where they can find it. So then maybe let's also dive a little bit deeper. So especially now with this agentic architectures, yeah, how do we keep this complex systems that now interact with different like databases, different services? How do we keep them safe and secure?
So I think there's a questions of putting guardrail. So like at the same time, like when we talk about like how to get them safe and secure, right? So we need to understand what the risks are and where in the systems that things are failing, and then we can put guardrails around where the potential failures can happen. So one kind of failures is I say it's like depending what's your case. So like first one kind of failure is when using an external API and you accidentally leak those sensitive data to external API. So some company do that by just like not using external APIs. Like you don't want to send more to like OpenAI, Anthropic, or Google on together. Some other companies maybe try to say like put a input guardrail so you can detect like sensitive information and then try to block those requests from going out. Or some other, yeah, so some companies like try to host everything in-house instead. Another kind of like risk is let's say I would say it's like also related to input is like prompt injections or like so prompt injections sometimes not all prompt injection can be harmful. Like it could be like annoying, like some people trying to get AI to like say bad things, right? But it can be like more harmful when you give AI models access to tools so you can execute things. So in that case, you have to like also do it from a different approaches, so of different angles. So first you have to like make the system not allow the system to automatically execute dangerous query. So say if you have given access to a SQL database, don't give it write access, right? Like you can give it only read only access, like it can select, but it cannot like delete or remove, update anything, right? So like the system just doesn't execute those. Similarly, if you give access to the email, then you can just give it read access and not like allow it to like send an email or like delete an email. So I think it's very important to make the system not vulnerable to it in the first place. The second thing is you can also like detect queries. So you can see like some people have tried to like do intent classifications of your query to see like what is the user really trying to do. And if it's like a bad intentions, you don't serve it. I think one really good practice that I do recommend a lot of companies do is like define scope questions. So like so somebody told me recently is like they went to a coffee shop when they have a bot to ask for coffee, and the bot just refused to answer any questions not related to coffee. And I think it's good because like it's saying, okay, if you do create a chatbot for the enterprise, right, to talk about like car insurance, there's no reason why it should also like respond to questions about immigrations or like vaccines. So it's very clearly like detect like whether the query is in scope for it or not, or just reject it. So any other queries could be like the model can reveal sensitive information. So I think one thing is just like let's say like you give model access to a database, and then the model retrieves the information from the data. So maybe Alejandro, right? You create a request, but then your data and my data in the same database, and the model can retrieve not just your data, but also my data, and so can reveal it to users. So that could be like a risk. Another way it could happen is because a model was trained on sensitive data, and then as the inference time, it was like regurgitate the information from the trained data. So the solution to this is like in the first one, you can build a model to predict. So there are a lot of like PAI information detector. So I try to detect whether the PAI was like included in the response and block it. Another solution is just like not train model on sensitive data in the first place, but it's harder to enforce because a lot of us are not building our own models. We have to depend on model providers. So I do think this like it's very important to have more transparency around training data. But unfortunately, companies are just becoming more secretive on the training data because training data is the competitive advantage. So companies just don't want to reveal too much. So there's like, they say we don't want competitors to know, but at the same time, it can protect them from scrutiny and like legislature. So yeah, so the whole space is quite scary.
Yeah. No, that is really great. I mean, I think the topic of yeah, safety, security, guardrails, yeah, could be its own deep dive. It does feel like we're back in the 90s with SQL injections. Yeah, and I do remember you in one of your posts slash documents. You had a very nice overarching architectural blueprint of basically the archetypal design for yeah, agentic systems, which has basically the input guardrails, the output guardrails. So
Yeah, I can put it. I think it's like a longer talk. So I don't really want. It's just like it's pretty complex system. So yeah, so like you have like so basically context construction here. You have guardrails. So basically you want to put guardrails everywhere the system can fail. Like if it's like fail as an input, do it. If it fails as an output, do it. If it fails as like retrieval, do it. So yeah, so guardrail is just maybe like I was like fancier try cache.
yeah, yeah, yeah. That's super interesting. Okay, so let's yeah, maybe ask one or two more questions before we wrap up. But one question that I think has come up, or multiple questions that we can, I guess, reduce to a single one. We have different people with different backgrounds. I think you know, some coming in, you know, for with in PhD or yeah, basically still at university. Others in software engineering roles, and others in machine learning engineering roles. So yeah, what career advice would you give for someone yeah, that wants to get into the field, or basically into a job of not just machine learning engineering, but specifically AI engineering? Yeah.
Oof. Bad career advice. I feel like career is something very personal. So I would probably try to understand. Yeah, I think it's really hard to give like blanketed advice that works for everyone because sometimes it works for me, it works for my friends, but it's not working for other people. And at the same time, I try advice that work on my friends, it just doesn't work for me. So I would say it's like yeah, I do think the one most important skill is like learning to learn and then problem solving. Like would probably spend less time, like I don't know. So there's some heuristic. One heuristic I forgot the name of it, but basically the idea is that how long something will last in the future is the same amount of time that it has lasted in the past, right? So like so say like if something has been around for 10 years, then we can use heuristic to estimate that it can be lasted for another 10 years. So relationship is a similar relationship, like you just start. Oh yeah, linear effect. Thank you, John. So the first thing is like if you in a relationship with someone, like you just started dating last week, it's unlikely like you don't want to plan something like a year in the future. But you've been with someone for like 4 years, maybe it's reasonable to like plan something a year in the future. So the same thing. It was just like a lot of news things that comes out. A lot of them, probably some of them will be very important. But then if they're really important, just like wait a little bit, like and see if that's the case. You don't immediately have to jump on. Or like if you jump on, do ask questions. Because a lot of marketing space might be like actually a compiling what I call like marketing speech translator. Because sometimes we'll come like, oh, he has this fancy technique to do this and that. It's turned out to be something very simple, but dress up in something. Like let's try asking a lot of questions. Also like when I read something like who is publishing it, because sometimes for example like you see like some startup coming out with like crazy exciting things, and you realize it's like everyone who's pushing for it actually investor in the company. So like understanding who are like propagating the information. So basically just ask a lot of questions.
Well, that is great. That is great. And I really like that point of, yeah, also the fundamentals and the things that will last. I mean, you highlighted that RAG concepts like that, have been, there for a long time, and that proves its resilience. And you do have also a very nice blog post on measuring, career progression. I think you do delve into some similar areas. So indeed, I think, unfortunately, we are now out of time. We have had a very, very great discussion with a lot of really great questions. So I do really want to give a massive, massive thanks to Chip.
I think
Great presentation. Yeah. Sorry, please go ahead. Yeah, Chip.
Oh no, thank you so much, everyone. I really appreciate your time. And I'm sorry if I spoke too fast, and I'm sorry I couldn't get your own the questions. I'm on social media. So yeah, please say hi. I'm pretty bad social media because I find incredibly distracting. So everybody has this fight of like, I know that like something like LinkedIn and Twitter could be good because it help me useful information, but like it's like trying to balance the costs and benefits. Sometimes yes, it can give me like 10% information, but like 90% of it is just like distractions. So anyway, and so yeah, I don't know how to answer that question, but yeah, I hope I see you all at some point in the future. And please, if you reach out, I will try my best to like respond, but sometimes I cannot get to like one of that. Yeah.
Yeah. No, and this is really great. So Chip, I think yeah, the whole presentation was great. The questions also were great. And one reminder that indeed the talk will be recorded and is available in a few days in learning.acm.org. So you will be able to replay it multiple times in case you missed anything. So nothing to worry. As all this information is going to be available there, as well as the slide deck, which was also shared. Please, also a reminder to fill out our quick survey. You can suggest future topics or speakers. So please do take a moment to fill those up, as it helps us to make it ever better. So on behalf of ACM, of Chip and myself, thanks again for joining, and I hope you join us once again in the future. And with this, we conclude our talk, and we wish you a great week ahead. Thank you all.
Questions. Can I get the questions that I couldn't get you? So I tried to address them.